some stuff, some links maybe.
Awesome, guys. Enjoy. This is rad. Take care.
All right, so we're live. So yes, this
Fantastic.
is another episode of devOSH Live. This week we're going to talk about the Maker Chip magnetic version again this week, I guess, since Kevin got a new update, some new designs to look at, and I added another project to the repository, a potential project, that being a Libre Silicon project. It's a little more advanced, but I think it'd be fun to try that. And there's a new services out there, and I'd like to get Mithro on the show eventually to talk about it. He has this new company called wafer.space, which does silicon chips for really cheap. And I think that would be fun to try. So that's something to look forward to in the future. There's a lot of projects listed now. I want to make sure that we have plenty of ideas flowing. And I'd also like to start getting feedback during the show as to what direction we should go. So I'm looking into getting some surveys set up so that we can see what people want to work on, what's the newest, coolest, what does everybody think is the next best thing to work on. It's supposed to be a community effort, so I don't want to just do things and show off. I want other people to contribute, and I want other people to come on and share their projects. So it's not just me hanging out, showing off, whatever I worked on after I come up with it, because that would be kind of, a little bit self-defeating or whatever. It's not a community effort if it's just me. So the Maker Chip project is kind of mostly Kevin here. Over the last couple of weeks, we've been covering the progress of the Maker Chip and the magnetic standard, how the 3D prints are coming out, kind of how the mechanicals are working out. It's a very mechanical project so far. So there's been 3D printing, there's been laser etching, there's been UV printing, lots of cool stuff going on. So let's go ahead and get right to it then and see what the update is for this week. And then we can circle back and talk about other topics afterwards.
Yeah, it's really not that big of an update.
Okay.
I've been working on it on and off. I think it took a little bit of troubleshooting to tune in the settings for my printer to get the right tolerances. But one of my goals at the moment was to essentially build we have a brand new the Eufy Make E1 UV printer. It does absolutely a phenomenal job at putting full color UV designs onto a flat surface, or if you have a jig, you can rotate it and things like that. And I wanted to experiment on how I could take that and build a jig where I can place the Maker Chip into and get consistent placement and spacing on the actual platform. So there's, a small plate, a large plate, and you could essentially batch out as many Maker Chips as you can fit on the plate itself. And I wanted to make that into a structured jig where you can very, very quickly place a new chip, start the printer, swap it, start over and over and over again very consistently. And one of the hard things to do right now with the Eufy Make is it doesn't come with any sort of, I want to say, alignment tools. there's a couple startups, not startups. There's a Kickstarter out right now that is specifically building a product for the UV Make UV printer so that you can have alignment on the bed and have just like a CNC machine would. You could, you know, align your different pieces. But for me, I knew that for the maker chip, it was going to be the exact same shape. It was going to be the exact same size, have the same magnetic properties every single time. And so I just wanted to build a really quick footprint that I could pop that maker chip in and run the design through. I haven't actually done any of the updated designs yet. I've got a couple logos that I want to put on some of the maker chips and send out a couple of them to a couple YouTubers, a couple content creators. They have their own brand and have shown interest in some of the maker chips. So we're prototyping a couple of those to see exactly how well it works and how it goes. And I kind of wanted to show off what that looks like. It's super simple. Yeah, let's share my screen here.
Okay.
Share screen. Entire screen. Yeah. There we go. All right, so let me actually.
Okay.
Okay, so I mean, if anybody is interested, feel free to reach out at any point and ask if you could get access to these files. It's the exact same file that has the maker chip designs already built in. And it's simply just another folder here, another project that has all these pieces together. But underneath is the original plate that goes onto the UV Make itself. And so this sits just on top and it has some clips here on the edge that kind of hold it together. I ended up having to print this into 2 sections because it wouldn't fit on the printer. So I ended up having to cut it in half. And I made these joiners to go on the top and bottom. They're friction fit, but you can definitely glue them in if you want to have a more permanent fixture to it. But underneath all of it, I have spots where I can put the exact same magnet and orientation so that you can essentially drop these down in there. They'll snap together and they'll self-align in the right direction. I wanted to keep the tolerance pretty tight so that there's not a whole lot of wiggle room forwards, backwards, up and down, so that every single time you put this in here, it should be the exact same location for the UV printer. So if you make a single file, all you have to do is duplicate that file, swap out your design, and know that the location of each one of these chips is the exact same center location for the print to happen. So you end up getting a lot more accuracy, a lot more consistency, and overall efficiency is dramatically improved. And so I've got everything kind of put together here. These files are ready to download for anybody who needs them, if they want to replicate them. I am thinking about just making a separate blank version that doesn't have any of these footprints. So you can take that solid design and you can just make whatever jig you want for whatever project you want. But for the MakerChip 2.0 standard that we're trying to build, that's specifically what this is built for. And if I take it one step further and actually pull up the 3D printable file here, open up Bamboo Studio, just to kind of show you the details of the printing process. And ideally, it can give you some insight on exactly what the best settings for putting everything together, more or less. And again, I can post this onto the GitHub as well, so you can grab that file if you need it. And if you want it sooner, you can always reach out and I can send it to you.
Yeah, so the files are going to be in a interchangeable format so that people can open it with other printers. Okay.
Yeah. So it's a 3MF file. So the saved file here is a 3MF, which is compatible with Orca Slicer, Bamboo Slicer, Prusa Slicer. There's pretty much any open source slicing software can open that file.
Okay.
I will have specific colors and settings for my specific printer, and it'll work best because I've tuned it for the printer that I have access to. But you can open this file and change those settings for whatever printer that you have. So it's pretty cross compatible.
Good. I'd like to get some other printers like available so we can try it with different ones and kind of look at the setup for the different printers. I know that not everybody's going to have one of these fancier printers.
Yeah, and I want to say that the biggest difference is just your build volume. Right now, I've got this set up for the H2D, Bamboo Lab H2D, which has a pretty large build volume comparative to a lot of other designs. Like for example, one of the most common ones is the A1 Mini, which is an absolutely small footprint, and this plate doesn't actually fit on that design.
So you have one or something.
Yeah, if there's enough requests, you could definitely take this and make one specifically for the A1 Mini. Cut off the corners here, so I can take this.
Yeah, you can slice it in half or whatever.
Yeah, I can slice it. I can slice it into another piece. I can even rotate it 45 degrees, cut the corners off, and still get 90% of the functionality of it. So yeah, there's a lot of options there you can do.
Yeah, I think that having people kind of have a starting point for the plate. It looks like it's just a duplicated design. I'm assuming it would be pretty easy to create different sizes based on what you've given. You could probably, it's not parametric. I'm assuming it's all kind of.
No, I can make it parametric. This was all really just the first version. I wanted to really get a feel for it and print a couple prototypes and see exactly what improvements I can make. Because my intention is to have this kind of be a workhorse. I want to use this on making our own chips, printing in the designs on it, and I'm hoping to batch out a lot of that to improve or just increase the overall amount that we can make in a single day.
Yeah.
And it really does bring down the cost dramatically. If you can really spread that load over many batches, it really does help. And so I wanted to go through a couple of rounds there first before making any sort of changes to it. I also knew that the MakerChip standard here is pretty consistent. There might be some small variations that happen in the next couple of months or so, but for the most part, this is the standard for the MakerChip, and I figured there didn't need to be that much variance to require a parametric model, but that is possible.
Yeah, I think parametric would be cool, or trying different patterns, like a hexagonal pattern or something like that. So is this thing something you're going to just have like on display somewhere where you would just set it down and then put the chips on it, or would it be like something you wear? I'm thinking it's probably set and have it there.
For this specifically, this is a functional jig. This is primarily used for the let me pull it up here, the Eufy Make. Just
to hold them in place.
That's it. That's exactly it. So I'm gonna just type this in real quick. Look at their website.
So the volume on this thing can't be exceeded. So you probably already kind of designed it around the plate size or whatever, right? Where did you get access to one of these fancy Eufy Make printers?
The local makerspace here in town has one. It was a recent addition, and I saw them test out a bunch of different samples, and I really wanted to try it. It was a perfect use case to have the MakerChip.
Yeah, I think it makes a lot of sense when it comes to 3D, like adding on to like a flat surface for like a 3D printed chip. you don't have to waste a bunch of filament trying to make these multicolor prints. You can just use this magical machine.
Mhm.
It's really cool.
Yeah, it's definitely not everyone's gonna have access to it. That's for sure.
Maybe we
But
could batch them or have people submit their image and
yeah, yeah,
something.
that's exactly it. If and it's kind of like how PCB services like PCB Way or JLC, like a lot of the foreign and domestic services will batch. They'll
Mhm.
wait for a batch to fill up before printing off, and that helps them to reduce the overall cost because they're filling up the space and the time. We
Yeah.
could do something very similar.
Okay.
Definitely a possibility.
Yeah, I don't know about the shipping logistics. That can be a little tough. But maybe having it like if you print it off for like an event or something like that, I think that would make more sense. Like if we wanted to make a batch for like different makers, they're going to show up at Open Source.
Yeah,
And we can say, hey, if you want to customize one of these chips, just send me whatever format image that you have. And I guess it has to be scaled or whatever, right?
yeah. The actual design work is pretty straightforward. I already have a template. In fact, I'll let it load here in the background. It takes a second to boot up, but I have a template for it already. And dropping a design in there would be super simple.
Okay.
Just a hot swap. So I don't think there's a whole lot of work that needs to be done there. You just have to set up the initial file. So I think if we wanted to do that, if we wanted to offer that service, then we would have to have a minimum batch order size, saying like, hey, you have to order 100 of them for this to make sense logistically and shipping and all the other factors.
Right.
And at that size, it's a lot more convenient. It self throttles the amount of people that actually use the service. For example, if you could just buy a single poker chip, when it'd be $5, then we would have, hypothetically, we could have thousands of people request it and have to send out individual shipping for all of them. So bashing them out kind of helps keep things sane.
Yeah, I think the shipping logistics would get tough for this. That's why I think, like, if you make them for like a specific event, they could just meet you there and then you just hand them chips. Or even if they can't show up to the event and they want to be represented there.
That's very true. Honestly, that's not a bad idea. Having a bunch of blank poker chips that already have a template design, and if somebody wanted to, they could come up and request X amount of poker chips, and we could print them there on the spot. This machine is incredibly quick. I would say,
but you have to bring it with you. That's kind of tough. But when it costs $2,000 or whatever.
Yeah, that's very true. I definitely don't think I can take it with me for this this year, open source, but it's definitely something that we could do in the future, because I don't think the makerspace, they just got it. I don't think they'd be willing to let me drive 24 hours to San Francisco just to print off poker chips.
No,
it'd be a pretty hard sell.
Yeah, I think with their new fancy machine, that would be very difficult to convince. But yeah, maybe if we could get more funding for our initiative, we can get our own, and then nobody's going to stop us from bringing it, doing things with it. Like having a 3D printer that we could bring with us to events would be kind of cool. I think the Beagleboard guys brought a 3D printer to the SuperCon, and I think for something like this, I think you'd want to just create a whole bunch of like slugs or whatever, and then once you have like the Eufy Make printer available, you could just print things on the fly. You could go like something less expensive, like a sticker printer. I know they have some like thermal printers or whatever that you can get there. You can just print things off real quick and then you can just stick it onto the chip. I mean, it's not great, but it's something we can budget for in like a couple of months, whenever the event is. And then we can say, oh, next time we might have this, and this will be cooler. And of course, you'll have the examples of the Eufy make. It's just like, it's going to be like a photo quality print, right? It's pretty much like a regular printer right onto the service.
And it's just like 3D printers. As you build up volume, as you build up height or 3D depth, as what they call it for the Eufy make, it takes longer because it's per layer. But yeah, it has full CYMK, true white, true black, and gloss. It also has a gloss layer, so you can get photo quality out of it, and based on design. So yeah, the 3D print that I built real quick, the jig, was a utility so that I could actually put the chips into the Eufy Make UV printer. And
my brain wasn't catching that, wasn't registering.
No, you're good. So
sorry.
That it's super practical for me, and I want to at least show off what's possible. And I want to trickle down from there. You mentioned a lot of great cost alternatives where a sticker printer is definitely a lot more cost effective. A laser engraver, a lot of people might have more ready access to an engraver, which we could build a jig or a platform for that. A multicolored 3D printing.
Right? I mean, to some extent, the same jig would work for holding them for a laser.
It's gonna be, if you want it to mount really consistently, you have to take into account the platform that the device is sitting on. Okay. For the Eufy Make, that's its mobile base. But for a laser engraver, let's say the F1 Ultra from Xtool, it has a 40 millimeter base plate where it has a bunch of tapped holes where they're perfectly spaced out. So we would just have to take that current design, modify the mounting system for the laser, but the same arrangement, the same system can be built for any single machine. We just have to do a little bit of work on making that compatible. And I don't necessarily want to do all of that. I don't know everybody's machine. So my goal is to have this example here, because that's something I need. But then leave it as a blank modifiable version that you can grab and modify for any machine that you need.
Yeah, and encourage people to share like how the setup routine and things like that for different machines would be nice. But a lot of them are going to use a similar slicer. They're all based on the same software. When it comes down to it, to an extent, they're very similar. And I think that having one example is probably going to get them most of the way to where they need to be. But it's always good to have, like, whatever hacks they needed to get it to work on, say this Soval printer or one of the Prusas. Then okay, this is what I had to do here. These prints are really straightforward and flat, and they're not going to be doing anything crazy. So you don't need a fancy printer if you're just making the chip part. But like for multicolor format, like making the print multicolor, that really depends on your printer and your EMS setup if you have it. So yeah, I think just having the resources out there, it will get people 90% of the way there, and then we can just kind of push them over.
I think you pull up a great point. One of the things we could do is, they come every single year to Open Sauce. Both years I've been there, and the year before I wasn't, they've been there. But there's a community or a website of every single makerspace on the planet, or at least close to. It's an open source platform. You just register your makerspace, and it lets people know what the closest makerspace is and what devices and tools they have available. So, maybe you don't have access to that kind of equipment, but there might be some equipment nearby.
Do you know what the web link for that one was?
I I don't. Let me look it up real quick. It's been a hot minute since I've looked at it.
I remember seeing something like this. Maybe it was on Hackaday. Space. There's like a wiki or something, right?
Yeah, it almost looked like a wiki.
You guys need me? Sorry, did I miss something?
No, we're just trying to look up this the Makerspace locator website so that we can share it with everybody. Because
Yeah, I gotta still find a way to give you guys access to this because like I want to like throw up, hey everybody, go check out protoboard.xyz from Delta Robotics. All right. No, yeah, I want to let you guys have the ability to pop these up. I accidentally put the protoboard.xyz up when you were talking about the the slicing software. I didn't want people to be oh, shit. Yeah. But all right, guys, I'll let you guys go back at it.
Yeah.
So, let me do some digging. The only one I can find right now is makerspace.com, but I'm not 100% sure which is the right one. I can go back into OpenSauce and look at past attendees or past booths that they've had, and I want to see if I can find it, the one that I'm referencing specifically.
Okay. Yeah, I'm seeing a page from Maker Spaces from Maker Nexus. Let's see if I can find another one. Makerspace.com.
That's the one I have pulled up right now, but I'm trying to confirm whether or not it is the correct one.
Yeah, that looks like it's Make affiliated or something. Yeah, the Makerspace magazine. Makerspace directory. There's a couple of them out here. Makerspace Dare. I know I don't have one around me. I've been considering making one, but it's a huge investment, and you have to trust the people that are going to show up at this thing, not to trash your machinery or watch over them like hawks until you get some level of trust.
So I'm looking through OpenSauce right now, and I think I found the one. But it doesn't give me much information on the website. The booth was called Find a Makerspace, and it says find the closest one to you at this booth, but it doesn't give me a link or a name or anything.
There's this thing called Makerspace directory. It's probably the one. Makerspace Dare.com.
Maybe. I saw that one come through as well.
There's also Nation of Makers. That sounds familiar. I think that was like a non-for-profit org. Yeah, we can look it up and share next time. I think it's good to have people understand that, like, what kind of resources they have nearby. I'm assuming a lot of people that are watching us are already kind of there, and they already know where to go. If you're in California, like, there's a lot of them around here. Like where I'm at, there was one, but it was miles away, and it wasn't the greatest. It was kind of slapped together like a trailer with a bunch of printers in it. It's like there was room for improvement. I think it's good to have like ventilation and like proper like air conditioning and all these good things. So especially
that's
soldering,
so funny.
You want to have like some kind of ventilation or like solder hoods or something, maybe even
air moving.
little bit of like a little bit of air
A
extraction.
breeze, open window, something. Yeah. Yeah.
Yeah, if it's in your garage, then open the door when you're cooking the chips or whatever, you know.
Very
So
true. That's so funny that you mentioned that. Yeah, I think that's spot on. Maker spaces are definitely hit or miss. It's really, really rare to find a really good maker space because I mean, think about it. It's a very transactional location. Unless you're a part of a university, those same people do what they need to and then they leave. It
yeah,
passes through constantly. And
yeah, I didn't
so
even think of that. I have a university
it's
here in town. I could
oh
just
yeah.
go there.
Universities are also hard because a lot of times it's locked down to like being a part affiliated with the university, a student, professor, or some
Yeah,
extension of that.
yeah,
And it's not always open, but the benefit of the university is it's well maintained. You have constant funding flowing into the program, albeit they may not have the best equipment, but there's janitors, there's maintenance, there's a lot to fall back on to prop up the makerspace. So finding a independent, self-sustaining makerspace is hard,
yeah,
and it's even harder if the goal of the makerspace is to be community led, because
yeah,
people are typically very flaky, and unless there's a huge investment and personal gain from being a part of the makerspace, it's really hard to have consistent contribution to the space. And so,
yeah.
what we've learned, especially here, that the makerspace that I volunteer at, it's privately owned, and every single printer is at cost. So every student, every person that comes there has to get a membership. Number one, they have to get a membership. It's not expensive. Uh,
Right.
$25 a month for I think students, so
Yeah.
very reasonable. And you get access to some of the best equipment, even from university standards, some of the best equipment, laser cutters, engravers, brand new UV printer, an entire print farm of self-maintaining, really good bamboo printers, like
Mhm.
all of these great things that come out of it being a business model rather than community led entirely.
Yeah.
But the downside is it's now there's very little ownership. So if you have a student come through there for finals, they're building their architectural model, they end up, you know, not helping to improve the space because for them it's just another transaction. They're like, I got to pay for my print. I'm going to pay for the next 2 months so I can finish my final, and then I'm out of here. And so it's like we're
Yeah.
constantly trying to find the balance of how do we maintain the space and how do we keep engaging more people to come in. So it's definitely a challenge. Which I think the biggest upgrade was the makerspace that I volunteer at is in a shop, like a like a storage unit,
Mm.
really big storage unit, but it didn't have much AC to speak of, and especially here in West Texas, um, it is incredibly hot during the summer, like 110, 120 degrees inside that shop. So
Yeah.
we finally just installed an AC unit, and it's probably the best upgrade we've ever gotten because it's consistently uh, livable inside the space. So no, it's funny that you bring it up because I've um, I volunteered at Makerspace. I've used most of the equipment there for my own projects, so it's really
Mhm.
fun to have access to that. I tried my best for almost 3 years as a project manager over at a startup incubator in my town to
Yeah.
build a startup, or sorry, to build a makerspace, and that was nearly impossible to get off the ground because most the people that you're trying to convince, hey, these startups, these students, they need a makerspace. They're all academics who have no experience in that space at all, and they just cannot understand why we need to buy five $2,000 printers for these students. And I don't know, it's definitely challenging. Maker spaces are hit or miss, but when you find a good one, man, it is a gem.
Yeah, and there are plenty of good ones. It's just they're in bigger cities, and or in university towns, where they have enough people to sustain it. Around here, there's like finding enough people to like actually become members and keep up with their membership and contribute to like keeping it up a little bit. There was probably 10 people that regularly used the one that was in the town next to us, and it was not in a real good shape. It was kind of just like with boxes full of junk, essentially, and yeah, I think it takes a certain like person, like a kind of host for the thing that's going to actually be there like constantly. And I mean, I can't really put that much time into it, so it's not something I can do easily. I considered like trying, but it's like you're not going to get your return on investment in a place where there's not enough people to support it, and it's even then it's still difficult, and you're not going to like make money. It's not a money making endeavor. It's for making other people, like giving access. And yeah,
For
it's
the
just
most
really
part,
difficult to do the business like side of it, because people will be like, how are you going to pay the bills? And then you say, okay, then we'll charge this much, and then like, are there
nobody's
enough
going to
people?
come.
They're going to, yeah, nobody's going to pay for it. So it's
Yep.
like, wow.
Yeah. No, that is spot on. That is spot on. Yeah. Taking the business approach is definitely very risky, very, very challenging.
Yeah.
What we've found success in, or at least what the owner has found success in, is actually it's a supplementary. So it takes time to build up your inventory. It takes time to get all the equipment, because you can't just outright buy for all of this stuff. But he's found success where he actually rents out the space. Like he sells memberships to businesses in town, where he gives them access to the equipment and his expertise on how to use the equipment, how to prototype. That actually covers, a good majority of the costs of the space. And yeah, it's still, I don't think it's still revenue positive here. I don't think he's making profit yet, but every single week he's getting closer and closer to reaching that goal. And it's all about building something that you can sustain a good majority of it, and then slowly building up towards that critical mass where it can be self-sustaining and even profit generating at some point. So I do think that's possible, but it is very, very challenging. And just like any startup, you got to find a good, product market fit, figure out the people that are willing to pay for this, that can cover the cost of what you actually want to do with the space. So yeah.
It wouldn't hurt to have your own, like, your own online shop or something that you're creating in the space, as well as hosting the space. You could use the space to generate something, and use that to kind of pay for it a little bit.
I think I'm biased in this idea, but I'm curious to see what you think, Michael. One of the goals, one of the visions we have, we kind of see this happening, where dark factories and automated factories and assembly lines are going to become a thing. Every single year it gets closer to it. One of our goals is to actually have our own prototyping shop, be able to prototype an idea, manufacture it, test it, and repeat that process. We're in cycle repeat. And I think it would be really, really cool if manufacturing facilities had maker spaces as kind of a funnel objective, where you have your actual customers who are ordering things. So you have your manufacturing frontline, right? And then you've got your glass windows, and then an actual maker space where you can come and do prototyping. Your engineers, like working for the manufacturing shop, they can come and do prototyping, but it's an open space. I feel like that could very easily bridge the gap between, maintaining that space consistently, having revenue to cover the cost, but also getting people access to that kind of space. And look, how amazing would it be for a community to have, imagine a university student coming in saying, wow, this is where all the manufacturing happens. This company has been doing this for a very long time. Me, I'm about to graduate. I've had so much fun. I've had so much life experience learned in this makerspace that I will always use them. Any job I go to, they're the first people I contact. And so there's this, organic funnel that you can create out of it. I don't know.
Yeah. I think that actually happens in like the bigger places like M Hub in Chicago. There was like pick and place machines and stuff there, and it was pretty cool what they had. And I don't think it was all just there for random people to use. I'm assuming there was a business behind that. So I think you got to think in that way. If you're gonna put in all this money, you got to think, hey, buddy, this better pay off eventually, because I'm taking out probably a loan or whatever to get some of these machines. And yeah, you don't want to just eat any of that cost and just like, it just doesn't make any sense. To me, it feels like you'd want to start with like what you want, like what you need for your particular projects, and then kind of organically grow over time to a bigger shop. And then kind of like, it just kind of snowballs over time. But yeah, it's not easy. It's not easy. You have to have like a steady stream of income if you're buying these big expensive machines. Because I mean, just operating costs alone is going to be something. You can't just let everybody have access to it for free. You gotta think about, what it's going to cost, what's going to pay for all the stuff. And yeah, I think it'd be cool to have it something like that, kind of like for us here at the devEco kind of global makerspace. That's kind of like, hey, you log on and you do some magic, and like it goes off to like shuttles off to a specific makerspace with, whatever capabilities, and then you can deal with the shipping logistics and all this, and then that way you could have like a distributed operation, so you don't have to have all the machines in one place, and you don't necessarily want to have them everywhere, especially like the big expensive ones. But it's better to kind of have them localized as much as possible, so you don't have to ship them really far. It'd be cool to have like a network of places that we could leverage, and a way to actually, make it so that they'll actually want to participate. I'm assuming that would require monetary compensation or something
that's in it for them. Yeah, I would agree with you.
Like print farms, like that's like what they do, right? They take in orders from wherever, and then they print them and ship them off, right? And it's usually just like one shop per whatever, unless it's a huge one. There are a few of them, but
I've seen some big ones.
Yeah, I've seen like the when I went to Open Hardware Summit, there was a what was it? They used to make printers with the octopus one.
Oh, Octoprint.
There was they were a 3D
is it the
printer.
green one?
Yeah, they were a 3D printer company. I don't know if they're still around.
I know exactly what you're talking about.
They had a farm there that they would use. It's pretty cool. It was in Denver, so that kind of rounds it to like a specific one. I can't, for the life of me, I cannot remember the name of the place.
I know exactly what you're talking about.
But they were like cool and big at the time, and I think that they might not be around anymore. But yeah, they had like a bunch of printers in a row, and I'm assuming this happens a lot. Like what the print farms, like they kind of have the same thing going on, just printer, and then they just have batch like you order online and then it dispatches to the machines through whatever software that they have. It's pretty cool. Lowspot. They were interesting characters. I think they were actually using KiCad for some of their PCB design, if I remember correctly.
Interesting. Yeah, Lulzbot is definitely still around.
Are they?
Yeah,
Maybe?
yeah.
Oh, okay. Maybe I know that they were doing like some crazy like interchangeable heads or something at the time. It was like pretty cool. Maybe I don't follow the industry very closely. Obviously, I'm an electrical engineer and I mostly do printed circuit boards. But yeah, it's good to know, like, who's out there and what kind of technologies they use and like what, like, yeah.
I know you just said that you don't follow this industry a lot, so I don't know if you've seen this or not. But you're familiar with Prusa and Prusa printers.
Yeah, I met Prusa.
Oh,
at the Open Hardware Summit in Boston, actually.
No way, that's awesome. We almost met Prusa at Open Source, but he was too busy talking to the other cool 3D printing companies. Whatever.
Yeah. You just got to go to like one of those rep festivals or whatever. Something a little more like 3D printer centric. I'm assuming he wouldn't have as many people crowding around him. But I talked to him and his cohorts.
Yo, Kev.
What's up?
I'm sorry for interrupting, bro. I really want to show. Can you show the hat clip? Can you show Fixer's hat clip to the homies here that are watching?
Oh,
yeah.
Watch this. So this is what we're talking about.
Hold on.
We're literally sitting here talking about a bunch of stuff, Kevin. The poker chip stuff.
Right.
Watch. See that hat clip put on there? Now watch this. Yeah. Watch this. Look how sorry, go ahead.
Hold on. Don't hype me up so much, man. The actual magnetic chip is currently in the makerspace being worked on. I don't have it with me, but I do have a non-magnetic version. So unfortunately,
no,
I can't show the snap.
Cool. Oh, it's just so amazing. So like the clip, like it literally, you just pop, it like pops on just like it. I'm playing with you. I'm showing them your you can hear it. Poker chip and magnet thing.
Yeah, the clips and the magnetic like lock is quite satisfying.
Yeah, but
I gotta send you some, Michael. I gotta send you some.
I'm just here behind the scenes, listening in when I can and bragging about you guys. But keep going. Sorry.
I did get some of those neodymium magnets, the little round ones, but I have to find a 3D printer to kind of make the pieces. I was thinking of buying one. I was thinking of buying one, but I keep thinking, what am I going to do with this thing after I make a couple of things? Do I really want to do this? And every time, the world, there's enough plastic in the world, and I just, put the $2,000 back in the bank or whatever.
My recommendation would actually be to start off with a MakerBot Mini. It's only like $250, and it comes with, I think it comes with like 500 grams, or it comes with filament, and you have there's a marketplace. You can go and just like printables from Prusa or Maker World. There's millions of models out there that it's like doom scrolling. You go down there and you're like, oh my gosh, I want to print it.
Yeah, I think I want to use it to
the rabbit hole.
The 3D modeling part of it. Like I've been learning a little bit of FreeCAD so that I can kind of make models, and I don't have to pay anybody for the software. So I've been trying to learn how to use it. It's tricky. Even though I have CAD background, like from way back when I was in high school, there's a lot of knobs on there, and there's a lot to understand. I think sorts of stuff.
Being mechanical engineering myself, I find FreeCAD to be incredibly unuser friendly. It's an open source project, and they're getting better and better every single year. But in my opinion, it still has a long ways to go before me, who does 3D modeling almost every single day, in some form of capacity, I find it incredibly frustrating to use the platform. And especially when there are free options available.
Yeah.
Onshape has a free version. Your models are public. That's fine. For
Yeah.
practice, for building, I mean, who cares?
Yeah.
Fusion 360 has a free license. There's a lot of other options available that do a much better job. So I would actually advise against using FreeCAD until you have more experience, where you can then utilize the full open source nature of things.
Yeah. I've actually gone through tutorials, and
Mm.
I think the big part is understanding the different modes that it has. I think it has all the capabilities of like AutoCAD or one of the fancier,
For the most part, yeah. For the
but
most part,
it's
it's
figuring out how to do the said thing
mhm.
is kind of tough. Like you have to know the buttons, and
Okay.
it's not
Okay.
obvious.
I got a perfect question for you, Michael. Being electrical engineering, so your whole world is electronics, not so much 3D modeling.
Yeah.
If it existed, would you be willing, or would you be interested in trying an AI assisted 3D modeling software?
I think there's nothing like that out there.
There is, and my question is, how do you feel about it?
Well, since like I think a lot of people, they kind of lean on AI when they're out of their comfort zone, right?
Mhm.
So I'm more of a purist. I like to try to figure things out myself and like understand them to the like core principles so that I can actually, understand what I've done to the best extent. But then again, if it's gonna make like creating like designs like that are extremely complicated in a very short amount of time, I think there are some benefits to that. And it allow you to kind of prompt iteration. And I've only recently started doing AI experiments. I mean, I'm work for Samsung, and I only recently started using AI like not even a month ago. Like I don't really do that. I just use my brain or whatever. But
Okay.
I was like, people are like, you should look at it, try it out. And I did try, Claude and all the other ones, OpenAI. They're all pretty cool, but it's like, okay, do I want to pay for something I can do kind of myself? Probably not. If I'm going to use it, like I hope it doesn't cost too much. Is kind of the thing that I'm kind of, yeah. So you posted a link there.
I put a link there. Just look at it. The reason I bring this conversation up, and I wanted to get your opinion. We just started talking to a startup that's building a AI platform for 3D modeling, and it's parametric modeling.
Cool.
And so the way it works is you describe just like any other AI. It's prompt conversation. You describe exactly what you're trying to make, and it helps you define what that component actually looks like. So let's say you're making a enclosure. You say it has to be 5 inches wide and 10 inches long, and it has to have a lid with holes in it for venting. And that's the description you give it. And it builds that for you and says, okay, here's how thick I made the walls, things like that. And you say, oh, hey, sorry, I forgot to mention this needs to be injection molded, so I need to put a 1 degree draft angle on the sides of the wall. And the AI goes back and says, okay, I have to restructure this model to include a draft angle so that it comes up to the top. And so it's that conversational step-by-step that can give you a lot of initial insight on how to build it, especially for prototyping. If you just need to bring out a really quick prototype so that you can get your brain going, this was an amazing tool. I've tried it a couple times and it actually works incredibly well. My personal test for it, which was a difficult test for most CAD software, because it involves a lot of calculation, but I asked it to perform 2 things: a enclosure that has a Voronoi style venting on the sides of the box with the curved surface, and an ISO grid for weight reduction at the top for the lid. And I said, do that to my model. And to my surprise, it only took 3 or 4 adjustments before it got a really, really close enough example for me to say, okay, that's pretty good. That's pretty good.
Yeah, I like this. It looks like it reminds me a bit of like using code to draw the model.
Yep. And if I remember correctly, so the founder, we're thinking about for Protoboard, we're working with him to integrate the platform. So somebody prototyping in Protoboard can go directly to 3D modeling and prototype even faster. Hang on, buddy. Hey, I'm on a call, buddy. Watch out. And he built the platform off of an open source hardware kernel, where the actual 3D modeling is done at a kernel level on your computer. So everything he's building is what they're using for OpenSCAD. And so it is almost like a step-by-step improvement. And all he's doing, it's really funny, he's building the kernels, he's building the tools. They're the exact same thing you would have in FreeCAD. The only difference is he's exposing that to an agent. And so it's giving them the tools that they need. And part of it's the model. Not every AI model has great spatial understanding. And it really varies. It's not a one-shot prompt. It's not going to build it for you, but it does help you iterate your design, your idea over a certain number of steps. But I was curious on what you thought of it, because it's not in your realm. It's not your element of expertise.
Yeah, I think it's pretty neat. It would definitely help. It would help me learn essentially by using it. And I think a lot of people do that with AI. They don't realize that they're learning through the process. And
right.
Yeah, I think I've also I've heard about this thing called Flux for AI for PCB design, which is pretty cool as well. And I'm not against AI. I just feel like it kind of does some people a disservice to the people that actually do the said thing, for real. And they're like, I went to school and I learned for a long time to get to where I'm at, and now you're just coming up and doing it with a chat bot. And I don't. Yeah, it's a different time. And it's a real great time to be like a startup, because you can just
make anything,
all things so quickly now. And I think it's going to make for a lot of innovation, but also, as you can see, a lot of flop and bad things. So
yeah, I would honestly say, and I don't want to go over time here. I want to make sure that we're not going past.
I think we're at almost at the hour. 2 minutes.
I'll end on that note. I would agree with you there. I don't think it's almost exactly the same curve as the .com bubble. And I don't mean that from an investor perspective or financial perspective. From an innovation perspective, the companies that actually made meaningful progress using the technology, they're still around. Where 96% of the companies that were just building services or new business opportunities, sure, they might have made a quick buck, but they're ultimately didn't really make it past that threshold. I personally think AI is very similar. It's on a much larger scale. I don't think AI is going away. I think that's what a lot of people are like, oh, the bubble's going to pop. It's not going to go away. The tool, it's too freaking useful. But I think we're starting to understand what it's actually useful for. And all these services are just kind of a lot of dead weight, a lot of stuff to filter through before we find the true innovations. And
and kind
And
of whittle away a
Mhm.
lot of the garbage. I mean, they're spending so much money, and it's like a huge futures bet, and they're like, we're just going, it's gonna, it's gonna do everything, and it's gonna be magical, and doesn't matter if we're losing money and we're making fake money out of a nowhere kind of thing, but it's definitely, it's not what people are making it out to be for the most part, and smart people will continue to use it, and it will not go away. There's no way that after this point, it's like I don't think they're going to have like AGI or whatever. That's just silly. But
no,
yeah,
Look, I mean, there could be a secret lab hidden somewhere deep beneath the earth. I don't know. I don't think so. I don't believe that's even a realm of possibility. And
there's so much
like,
doom and gloom, and then there's like like crazy optimism. Like there's
mm,
not a lot of in the
both
middle.
sides of the scale. Yeah.
Yeah, I try to kind of take it like slowly and like adopt it kind of organically for specific needs if I need it, and like for work, I haven't needed it till now, so I don't see why I would start using it. But
Yeah.
it's an
Yeah.
accelerator for certain tasks. As long as you have the core knowledge, you can make it do what you would do a lot quicker.
hmm
And if you know what it's doing, and the output, it makes sense to you, you can tell it, hey, this is wrong, and fix it. It can actually be useful. But
hmm
if you're like somebody that doesn't have all the pieces, they're like just part of the puzzle, and you throw things at it until it produces something that works, and then you realize in the long run that it's like, no, you made a bug machine that's probably going to cause, like, I don't know, some kind of disaster. You know what I mean?
Yeah.
So
Yeah. Definitely
yeah.
face value. And it doesn't help that most of Silicon Valley, kind of the driving force behind a lot of the AI push, not the only one, but definitely partially to blame here, I would say. Their whole internal model for the last like 20, 30 years has been to, Facebook, Mark Zuckerberg's famous quote, go fast and break things.
Mm-hmm.
So that ideology has been adopted by every single one in Silicon Valley, where AI has just, tenfold that go fast
Yeah,
and break things
everything's got to be
mentality.
AI. Everything's got to have some kind of tie-in to it. It's
hmm
got to be the AI version of that thing now. It can't just be like, it used to be like IoT was a thing, and now AI is like, if you don't have AI at the end of your pitch, you're not going to make enough funding or whatever.
I feel
So,
personally attacked because I definitely had AI at the end of my pitch, 100%.
yeah, it's just, that's the new business like plan. If it has
hmm
AI at the end, the investors their eyes light up a little bit,
Ooh.
because they've heard a lot of the hype, and they've seen things happen so quickly with it, that it's like, oh, this could turn out to be a big thing. And then they not everybody's like, firing at all cylinders. They're just kind of like throwing darts and seeing what sticks,
hmm
or like some people will say it's AI, and it's like some dudes in India or something. I've seen
No,
that as well.
that's a big tech AI right there. That's I've only ever truly seen that implemented at scale, like in two different ways. When you're trying to autonomize a like almost exclusively human action, like shopping, or making
Yeah.
sure, like Amazon did, where they're tracking customers through a store. The technology wasn't ready, but I don't know, that whole debacle. And then I've also seen it where it's kind of like a temporary placeholder that becomes permanent. A lot
Yeah.
of humanoid robotics companies, a lot of Waymo, Uber, like there's a lot of platforms that are using real human drivers. And the
Yep.
whole thing is like, oh, this is temporary. We're training the system, but then it just becomes temporary for
Yeah, I think some of the humanoids,
existence.
like they're faking the funk and driving
Yeah.
like an RC, person essentially.
Yeah. I just had a conversation with these guys are cool. So they built, I don't know if you've seen them, but they built these headphones that have a ferrofluid display inside the
Oh,
headphone.
that's
And
neat.
you can see the beat on the
Huh,
fluid.
that's cool.
It's really stinking cool. And we just started talking to them. They really like the software that we built. They just moved to China to set up a manufacturing site, and they were talking about how every single person that they talk to in China is like essentially faking the technology's capabilities to try to make a sale. And it's like they had such a hard time figuring out who the right people to talk to, because it was just a nonstop, constant like onslaught of trying to figure out what's actually real here, because none of it was.
Yeah, that's tough. Yeah, you have to go to the shop and know enough about what they're doing to be like, nope, this is not going to work for us. And yeah, it's not easy. I mean, that's a huge time investment. And yeah, I know a lot of people that like they start out, and then they're like, all right, let's productize this, and they end up going to Shenzhen and like not knowing heads from tails or whatever, and learning on the fly. And yeah, it's rough to find like the right shop. You got to know people essentially.
Mm-hmm.
So,
Yeah, there's an advocate. There's somebody rooting for you on the other side, helping you make those connections. That's for sure.
yeah.
That's very, very true. We have limited experience. Like we've worked with manufacturers in not in Shenzhen but nearby for some of the artificial muscle tech that we've been doing. And
cool.
I mean, they're phenomenal business people. Their marketing business strategies, like they know how to get a hold of you and give you the best possible deal ever. Like that is all of it is upfront. You're like, holy cow, there's so many cool options here. But in the end, after you go through your due diligence process and find a manufacturer that's not only willing but also capable of consistency, it's definitely still rare. It doesn't matter where you are; it's still rare to find that one shop that can actually do what you need it to. And I think
it's not gonna be the
honestly,
cheapest shop.
no, it usually isn't. And they know that too. They know that. They have the confidence to upsell you on that. In my opinion, I think, and I'll jump off the topic, but in my opinion, I think the biggest indicator for finding a good shop like that, especially if you're building a product overseas, is communication. What is their actual communication like? Are you talking to their application engineers directly, or are you talking to some salesperson through 3 different channels and it's all broken English? It doesn't sound like it'd be that difficult, but it is very, very hard with your time zones, your working schedules, your holidays. It is incredibly difficult to find a really consistent company shop that will communicate with you effectively. And I think that has probably one of the biggest indicators of how well you're going to work with them and how well they're going to work with you.
Yeah, it's just kind of get in, like, kind of set a rapport and find your wavelength or whatever. And if you guys can sync, then it'll work. But if you can't, then it's like, well, you might need a liaison or something like that. And that just,
and it hurts. It hurts so much more here. If you get ghosted here in the US from a manufacturer, you're like, oh well, I guess I'll go find another one. But if you get ghosted by the only manufacturer that you were able to find, you're out of luck. Like there's no way for you to communicate or find, other solutions out there without somebody boots on the ground trying to figure that out.
That happens when they have like a niche market or something that's very specialized, and they get to pick and choose their customers, and they usually go with the big guys. And you're just kind of like as a smaller player, you don't have a whole lot of leverage, so you get pushed to the back of the line. It happens a lot with semiconductors. Little guys are like, there aren't any players. It's like you have to be like an Apple or somebody huge to actually get in line, and then if you're lucky, you get put at the end of the line, and only if you know somebody, or there's got to be like an inside kind of player for you. So
we could talk about this for a whole nother session on overseas, just manufacturing in general. I mean, it's a topic that I enjoy. It's hard. I'll say that.
Yeah, I don't have as much experience with it because I usually work with embedded projects that didn't really require the paper thin margins of consumer electronics. I only did a couple of designs like that because I usually didn't want to deal with that because I know it's fraught. There's a lot of pitfalls and the supply chain is not great. And then the pandemic hit and everything just fell apart. Even like regular embedded developer, like PCBs for like industrial, we're having problems. And I was like, oh boy, what am I going to do? Because I was like a PCB design engineer, like contractor. And I was like, oh, well, I also do firmware. And so I just said, okay, let's find whomever to do firmware for, because I like making printed circuit boards is like really difficult in 2020, 2021. And so I ended up, contracting with big players and ended up eventually taking, a job at Samsung doing firmware. I don't do PCBs or VLSI or anything like that for them. I just do kernel drivers, which is where I kind of started a firmware developer. But I did work for a PCB design house and manufacturer or at least assembly house. And I've worked with many PCB fabs and all the different ones, in the China Shuffle, JLC, and all those guys. And yeah, so there's a lot to know, and you have to really you have to learn by doing, essentially, a little bit. And that's kind of how I learned PCBs. It was all industry experience. I didn't learn it from school. So
you cannot. Please, for anyone who's listening, if this ever gets posted online somewhere for people to watch in the future, you cannot learn this information in school. You're gonna get into a class. It's all about manufacturing. It's all about industry or business. These are lessons that you just simply cannot teach in class. And it's not that they haven't tried. They really have. MIT has great classes for it. But the problem is the industry is so dynamic. It shifts so fast. You have to be out in the real world to get that real world experience, because the next month it's going to change.
Yeah.
That's the whole reason why supply chain logistics are so incredibly difficult. It's because it's constantly changing and moving. I mean, the war in Iran right now is a great example. It's completely disrupting the supply chain, and it has nothing to do with most of the supply chain.
Yeah, well,
it has a huge impact.
It's kind of what drives the supply chain.
That's true. Yeah, I mean, the fuel and all to do that. Sure, but I'm saying is like the most conceptual thing that people think of is the raw components. The inputs and outputs of the system aren't the only thing that affects the supply chain. So it is something you just have to go. It's very intimidating, but you just have to jump in feet first and go. Let's start talking to people. Let's start figuring out how to do this, because that's the only way you're going to start jumping from person to person until you eventually land in the right spot. And you're like, okay, now we can take the next step and start working our way up.
Yeah. School of Hard Knocks.
Yeah.
All righty, we should probably call it for today. It looks like we're about
Mhm.
15 over. So it was fun. Next week we'll probably have another update from you, I'm assuming. Hopefully, we can
Yeah.
get,
I make
some
no
other-
promises. But my goal is to keep working towards the design, keep making upgrades, and keep making updates to it. I would like to have some more PCB stuff done next week, but we'll see. We'll see.
Yeah, and that's when I can like kind of once you have like the spec for the PCB stuff, I can start contributing as well. That way we can kind of collaborate on that a little more
Mhm.
closely and get
I
something that's a little.
I would love some help on the base. So I've got my own personal design that I'm building for Delta Robotics, our company, that I'm
Mhm.
going to use as the example.
Okay.
But it's just a chip itself. I would love to start working with you on creating the actual base unit where the chip interfaces with,
Okay.
and we can have a conversation about it later. But I think that would be a lot of help, is having somebody jump on that.
Yeah. So like how to power it,
Mhm.
what kind of controllers to put in there to talk to the chips if they need to be talked to.
Mhm.
Yeah, I would try to keep it simple though, especially like for something it's going to be wearable. You want to make sure that it's not going to like be overly complicated. Maybe use like regular off the shelf alkaline batteries or something, That's what they do a lot of times for like badge designs. So you don't have lipos exploding and killing people.
Yeah.
Yeah, but I can help with design of all the electronics. This is like most of it
Perfect.
can be really straightforward. Like you guys had a couple of LEDs,
Mhm.
nothing too complicated. But it would be fun to try to put a little more brains in there and make something that's interactive.
There's room. There's room. I've got an AT Tiny in there right now, which is programmable. So I
Yeah.
can have RGBs. I can have a buzzer. I can do a couple other things in there. But for me, for the first iteration of it, I am just making a simple LED platform.
Makes sense.
Because I'm more so focused on the visual aspect of it, not so much as functionality, at least not initially. We can talk about it.
Yeah.
But the
I think
standard is
having
supposed to be able to
LED
accommodate.
at least turning on. This is super simple.
Mhm.
This doesn't take an electrical engineer. This takes like a fifth grader. LED plus a resistor plus battery. We got this. So, yeah. All right. Cool. So I guess we'll call it for this week. And let's Fixer wants to jump on and say something.
No, just thanks, guys. Appreciate it.
Did you guys
I'm
enjoy it
starting.
from your end?
I'm sorry.
Did you guys enjoy it from watching from your end?
Yeah, of course. And also, I think it's pretty awesome. I'm really trying to kind of like slowly but surely carve this time out. I hope you can tell. Like I literally have been here, but it will start to become the muscle memory as well. And I'll start to be able to participate more because I really want to.
Okay, and since we were like a half an hour late today, pushing it an hour out to 7:30.
So
for me works fine. So that would be, I guess.
It's always been 4:30. It's always been 4:30 my time.
Yeah, so 5:30.
Starting at 5:30 going forward.
You think that's good?
Yeah, I think I have the invite is set on the Dev Eco, so I'm going to move it forward here, and then everyone that's already on there.
I'll add it to the Markdown page for the repository as well.
I just updated the global Google invite.
All right, good.
And wait, let me make sure that you guys can modify that. So
it would be good for us to be able to start the stream as well. Earlier, I was on here, but I was like,
I'm really sorry about that. Like I kind of like I have not been scanning Discord as much this last couple of days, and so like I just scanned what you said, and I was like, oh, an hour later, okay. Well, I think I wrote back like, oh, now is good, or regular time, or later is good, and then I think I just assumed that you guys said an hour later.
I think an hour later is probably good for like getting dinner done and get it, because I think he's in the same time zone as I am, or the adjacent one, so it's right around the same time. And dinner time, like it's rough trying to eat real fast, and then come onto the show and not be like, ready to take a nap.
Yeah.
You know what I mean?
Yeah.
And pushing it out until after the thing can be rough.
Well,
For
hey,
sure.
let's get I'll get a selfie with you guys real quick, and we'll put Jeremy on the screen there. We'll put one of Jeremy's
Oh boy,
comments. We'll put one of Jeremy's
troublemaker.
comments on the
He's
screen.
going to say something inappropriate.
Is he?
That's what he does.
No, I have it up there. Californians have yet to discover ventilation and air conditioning. There's central
This is
air
true.
and central heating in this house.
Yeah, but you don't use it.
No. Well, that's the thing is like in San Diego, at least, you drive with either your heater on blast and your windows down, or your air conditioner on blast and your windows down. But your windows are usually always down, and then you have heater or AC on. But here, let me take a selfie real quick. Let's put which one? Open up a Lisp repo. Compensate me with your enthusiasm. There you go.
There we
That
go.
one. Okay, so now Jerry's there. You guys ready? Let me see. I don't have any of my vapes here. Okay. Okay, cool. devOSH. All right, guys.
Next week
Yep, keep in touch in Devico.
at
And Delta
the
Robotics.
new bat time, same bat channel.
And don't forget to check out Protoboard.
Yeah,
Yeah, don't look at it. Go do it. We dare you.
press the button.
You've been dared.
All
All right, guys. Have a good one. I'm gonna end it. Oh, wait. We do this. I forgot.
I'm leaving. Sorry.
Down for real.
right.
Oh man. Okay, guys. I'll take it easy, Mike.
Good day, sir.